So this video is all about a process known as combining like terms, which is used to take long variable expressions and condense them down into shorter versions that perhaps make them easier to work with, but in otherwise sort of reduce the amount of clutter in expressions that have lots and lots of different terms that are pretty similar and could be combined into smaller ones. This is a video that is essentially the second part of the distributive property video, because using the distributive property and combining like terms are often done together, and these two lessons are sort of the culmination of the negative numbers chapter that we've been working with in class so far, because combining like terms and using the distributive property require all of those different skills that we talked about as a part of adding, subtracting, multiplying, and dividing negative numbers. So speaking of the distributive property, let's take a quick review of the distributive property. Go ahead, pause the video, use the distributive property to simplify these expressions. For the one on the left, you can find out what the actual value is, but for the one on the right, you're just going to use the distributive property. So go ahead, pause the video, work on those, and come back when you're ready to move on. So for the first one on the left, we could make 3 plus 6 equal to 9, and 9 times 5 is 45. But instead, if we use the distributive property, 5 times 3 is 15, 5 times 6 is 30, and 15 plus 30 is 45. For the problem on the right, 5 times x is 5x, 5 times 7 is 35, and of course we still have that plus sign in the middle. So we end up with 5x plus 35. Now for the one on the left, we could add those two numbers together to get a particular value. For the one on the right, this is actually the farthest we can go with this expression, 5x plus 35, because we have one term here that is just a number, that has a special name that we'll talk about later, and then we have one term here that includes a variable, and the value of this term changes depending on what the value of the variable is. So we can't really combine them together at all because 35's value never changes, but the value of 5x changes depending on the value of x. So there's a few different terminology things that we talked about right there that I'm going to ask you to write down. The first part is a term. Each part of a variable expression is called a term, and we can call them first term, second term, third term, etc. If they have identical variable parts, they are called like terms. So go ahead, pause the video, write these two definitions down, and think about the question, what if we ended up with something like 5x plus 12x? So write down those two definitions, come up with an idea about what to do with 5x plus 12x, and come back when you're ready to move on. Well, if we imagine the x not as a variable, but as perhaps a physical object like oranges, if we had 5 oranges and then 12 oranges elsewhere, how many total oranges would we have together? Now, that's a simple problem. We worked with things like that when you were in even first grade or so, when you were starting to put those things together. We would just add 5 plus 12 to get 17. Well, the x's, of course, aren't oranges, but the idea behind it is still the same. We have 5 of them, and we're going to add 12 more. And so if we break those multiplications down into the repeated addition, there's 5x, there's 12x, we're adding them together, that's x added to itself 17 times, so we end up with 17x. And that's because we have 5x plus 12x, and 5 plus 12 is 17, so it's this total of 17 x's. Notice that we can do that because we have a 5x and a 12x that both have an identical variable part. We're adding the same type of variables, so we can combine the 5 and the 12. Now, if we had something along the lines of 5x plus 12y, we could not combine them because the value of x does not necessarily have to be the same as the value of y, and even if we expanded it out, we would have 5 x's and 12 y's, and we can't combine anything like that. But because we have two terms that have the exact same identical variable parts, we can put them together according to that number that is attached to that variable, and that number has a particular name, which is called a coefficient. But we'll look at that here in just a second. Now we want to ask the question, well, what if we end up with something like 5x minus 12x? Go ahead, pause the video, see what you think in terms of what that might mean, and come back when you're ready to move on. So this is an example where we can't really use a physical object. We can't use oranges to say, well, what if we have 5 and then we give away 12? So we have to think about it just in terms of the numbers here. Well, those things that we said at the beginning of the previous slide, or a few slides ago, we said that the numbers multiplied by the variable have a special name. And those names are coefficients. And here, you might have come up with the idea that if we have 5 and we take 12 away, we're actually at a deficit of 7. We have 7 less than we need. Or, alternatively, just looking at, well, here's 5, and 12 is being subtracted, so 5 minus 12 is negative 7x. And that's how we actually go through and we combine the like terms, the terms that have identical variable parts, when we have some subtraction like that wouldn't make sense with physical objects. We just use the coefficients as they are. So here's 5x minus 12x. So go ahead and pause the video. You're going to write down the definition there with the yellow box that just moved around on you. Write down the definition of coefficients. You're going to need to write down this expression with it also, because that expression gives you the grounding for why the coefficients are 5 and negative 12. And notice that it's negative 12 because it's being subtracted. Once you've written that down, unpause the video, and we'll move on to slightly more complicated problems and the practice problems at the end for you. So now that we've talked a little bit about combining like terms and using the distributive property, let's put the two of them together. Now, sometimes we end up with something like this plus 10, where there's not a variable, it's just a number. This is called a constant. Go ahead, pause the video, and write down both the expression and the definition of constant, and unpause when you're ready to move on. So here we have a number of different things that we need to do. But first, we notice on the left we have a 7 times the parentheses x plus 3. In order to do anything with that, we have to get rid of the parentheses by using the distributive property. So 7 times x is 7x. 7 times 3 is 21. And right now we end up with 7x plus 21 minus 4x plus 10. And now we can do a little bit of combining. We have a 7x and we have a minus 4x. And notice that 4x is being subtracted, so it is a minus 4x. 7x minus 4x is 3x. And now we have some numbers, and we can, of course, add or subtract numbers together. 21 plus 10 is 31. So we end up with a final simplified version of 3x plus 31. Notice we can combine the numbers because they don't have variables. We can combine the x's because they have the same variable parts, but we cannot combine 3x and 31 because they are not like terms. They don't have identical variable parts. They have to stay separate. 31's value is what it is. It's constant. It is always 31. 3x changes depending on what x is. So now there's a slide here with some practice problems for you. Go ahead, pause the video, see what you can do with these questions here, and then come back when you are ready to move on. So for the first one in the top left, again, we have to use the distributive property first. So that's negative 3x plus negative 12 minus 12. And now there are no other x terms, so the x term is what it is. But now we have negative 12 minus 12, and negative 12 minus 12 is negative 24. I'll write it as plus negative 3x plus negative 24, or negative 3x minus 24. Those are the answers that you're looking for there. For the one in the bottom left, we have a distributive property over on the right-hand side of this expression. So 4b minus 2 plus 2b plus 2. Remember that 2 has to be multiplied by everything. 4b plus 2b is 6b. And now we have a 2 that's being subtracted plus 2. So the 2 that's being subtracted is actually a negative 2, because subtracting 2 is the same as adding a negative 2. This is negative 2 plus 2, which is 0. So all we're left with is 6b. We'll go over processes like that more when you come into class. So if that wasn't entirely clear, that's not a big deal. We will work on lots of practice problems like that. For the one in the upper right-hand corner, we have 4x plus 4 for the left-hand distribution. For one in the right-hand corner, we have 5x plus 10, because 5 times 2 is 10. 4x plus 5x is 9x. 4 plus 10 is 14. So we have 9x plus 14. And finally, in the bottom right-hand corner here, we have 2n minus 3n, which is negative n. And we have 2p plus 6p, which is 8p. And that's all we can do because p and n are not like terms. So when we're combining like terms, remember we can only combine terms that have the identical variable parts that makes them actually like terms, and that we're using the coefficients of those terms in order to figure out what to do. We have to keep a close eye on what's subtraction, what's negative, because all of those different pieces mix together to create this simplifying expressions tool that we call combining like terms.